So what is the difference between boiling and evaporation? What happened in evaporation? The most energetic molecule at the surface gain energy from the surrounding and escape. So the molecules which are there at the surface, they absorb energy and these molecules escape. We call this process as evaporation. What is boiling? When the molecules have sufficient energy and they can escape from any part of the liquid. It's not necessary that the molecules only at the surface will escape. So molecule can be anywhere. And if these molecule can escape at a specific temperature, at a fixed temperature, by supplying a continuous heat energy, so we need a heat source here. And this occur at a fixed temperature, means at a specific temperature, but evaporation can be at any temperature. So the differences, when we write the differences between boiling and evaporation, so evaporation only at the surface, where boiling can occur throughout the liquid. Evaporation is a slow process. Boiling is a fast process. Evaporation, we don't need a heat source. It can occur without a heat source and at any temperature can occur. But boiling occur at a specific temperature. Evaporation, we don't observe any bubbles, no bubble. But if boiling, when a substance is boiling, what we will observe? We'll observe bubbles formed. So these are the few differences between the boiling and evaporation. So for evaporation, without a heat source, you don't need any heat source or source of energy. Heat source should not be there like a burner or a stove. But in boiling, you have to supply a specific amount of heat energy to convert. And what is the similarity? The similarity is that in both the liquid is changing into gas. That's a similarity. But these are the differences between the boiling and evaporation. Is it clear, the differences between the boiling and evaporation? Then for particles have a random movement. Yeah, take the screenshot. I already shared this presentation with you on the group, so you can also check. All the details are there. Even there are more details. I will discuss specific point, but there are more examples and detail in the. Then the Brownian motion. What is the Brownian motion? The random movement of the molecule so random or zigzag movement of the particle is known as a Brownian motion. So what happens when the particles are continuously, like example, if this is a particle and this is continuously changing the direction, moving randomly, continuously changing the direction, what we call this kind of movement, is known as Brownian movement. And you can observe this movement. You can observe like a dust particles. If there's a light source and the dust particles are there in the room, so you can see the dust particles are continuously vibrating, continuously changing a direction. So the movement, because it's a random movement, and random or zigzag movement is called Brownian movement. But why the dust particles have that movement? What's the reason for that? So why the dust particles moves randomly? Example, if this is a dust particles are visible with the eye, so you can see the dust particle. What is in our atmosphere or surrounding? We have air. Air particles, oxygen, nitrogen, inert gases are there, carbon dioxide is there, but these air particles are not visible with the naked eye, you cannot see, but still they are present. So what happened? These air particles are hitting the dust particle continuously because air particles are moving randomly. So as these air particles hit the dust particle, what they will create? They will create a force. So when these air particles hit the dust particle, they will create a force, and this force will move this dust particle randomly. So if a question is, if you have a question why the dust particle does not settle down quickly, so what could be the reason? How you explain this? You will mention the heavy dust particle or large dust particle is colliding with lighter air particles which exert force on dust particles, cause random motion or Brownian motion, so does not allow dust particles to settle down quickly. So what happened? In our atmosphere, we have dust particles and we have air also. The question is why this dust particle does not settle down. Like example, if this is a dust particle and this is a ground, why it does not just settle down? Because of gravity, it should come down. So what is the reason why this dust particle is not coming down quickly or does not settle down? Because this dust particle is continuously colliding with air molecules like oxygen, nitrogen, carbon dioxide, even water vapors are there, and other inert gases. So when these air particles are colliding, they cause a random movement. Random movement means it can move in any direction. So due to this random movement, it will settle down, but it will take more time to settle down because it's not moving directly downward. It is moving randomly, changing the direction. So it increases the time for the dust particle to settle down. If we have a windy condition, what will happen to this dust particle? It will settle down quickly or it will take more time to settle down. If we have a windy condition, like wind is blowing, what will happen to this dust particle? Will it settle down quickly? So it will not settle down quickly or it will take more time to settle down. That is why when there's a dust storm, you will find whenever there's a dust storm, the wind speed is much higher as compared to normal days or wind speed at normal day. So because of higher wind speed, the particle have more energy, greater random movement. So as the particle have greater random movement, it will not settle down quickly. Is it clear, the concept of the Brownian motion? So what happens if the random motion is more? If the particle is moving or having a greater random movement, then it will take more time to settle down. Random movement means continuously changing the direction. Many times the direction is changing. So many times the direction is changing. This particle will take lot of time to settle down. But if this particle is having a less random movement, then what happens? It will settle down quickly. So windy condition, the particles have greater random movement, so it takes more time to settle down. How we can observe practically, how we can do this or identify or see the random movement? Take the screenshot, then how we can observe this random movement or Brownian motion? So to observe this Brownian motion, what we can take a jar. This jar should be made up of glass. The surrounding, the walls, the base should be glass. And inside this jar, you have dust. And at the top, you have a microscope. This is a glass jar or glass container. Now, what is missing here? Because to observe anything, we should have a light. So what we will do, we will have a light source. What is the reason? Because without a light, I cannot observe dust particle. So there should be a light source or the source of the light. So we observe through the microscope. This is the eyepiece of the microscope. So we'll observe from here. And why it's a light source? To illuminate the object so that we can observe the dust particle. And when you will focus on any dust particle, what you will observe? You will observe its movement is random. Means it is changing its direction continuously. Is this a Brownian motion? Is this a Brownian motion? Yes or no? The answer, the definition of a Brownian motion, it's a random motion, but it is not a curve. It should not be curved. What happens when the particles are moving? When the particles are moving for a small distance, they will move in a straight line. The random movement, but for a short distance, it should be a straight line. So this is a Brownian motion. The curve one, when we draw a Brownian motion, this is a random, but the thing is when we represent a random or continuous change in direction, so for a short distance, it should be a straight line, not curve like this. So when we represent a Brownian motion, for a short distance, it should be a straight line. So using this apparatus, we can observe the Brownian motion. Now some questions related to the topic we discuss about the properties of the matter and evaporation. So we'll discuss question specifically. Evaporation, changing state, and Brownian motion we'll discuss. Okay, question 2. Everyone should participate. It's not an issue even you say a wrong answer, but you should participate. Which statement about evaporation is correct? Question 2. What could be the answer? "17 students, so everyone should participate." So A is the right answer because evaporation causes the temperature of the remaining liquid to decrease because the most energetic molecules escape. So the particles which are left behind will have low energy. A substance loses thermal energy to the surrounding at a steady rate. The graph shows how the temperature of a substance changes with time. Which could portion, what could the portion PQ of a graph represent? Look, two things. There is a constant temperature 2 times. So it means it is changing the state 2 times. So if it is changing the state 2 times and it's a cooling curve, so means this point it will be gas and liquid, liquid and solid. So what is the answer? So what happened from P to Q? From P to Q, it's a liquid. C is the right answer. Liquid is cooling down. Because when you check the state, at this point, you have a constant temperature. At this point, there is no change in temperature. When the temperature is not changing, it means the state is changing. So if it's a state is changing, it means this was a gas, then gas was changing into liquid, which we call condensation. Then when the temperature change, the state does not change. So at this point, you will have liquid. and here liquid is changing into solid. So in the question they asked what happened from P to Q. So what is happening from P to Q? Because you have a liquid and you are removing the heat energy, the temperature of the liquid is decreasing. It shows that the liquid is cooling down. Is it clear? So because they asked from P to Q, so P to Q it is liquid and the temperature of a liquid is decreasing. So liquid cool down. Question 4, what could be the answer? Question 4. So Brownian motion is observed when a microscope to look a smoke particle in air. What causes a smoke particle to move at a randomly? It's because they're colliding or hit by an air molecule. That's why A is the right answer. Question 5. It is related to momentum concept. Question number 5. What could be the answer? So what happened? The gas molecule strike a wall, a container wall, a pressure to be exerted on the wall. So what could be the right answer? Actually, this is related to, I told you, I give you a hint. This is related to momentum. What happens if you increase temperature, the pressure will increase, but even at a constant temperature, the gas molecule will exert a pressure. Rebound means, the term rebound means bounce back. So example, if you have a container and this container is filled with a gas at 20 degrees. So even a gas is at 20, gas is at 30, at any temperature, the gas molecule will collide with the wall. At different temperature, rate of collision will be different, but still they will collide. So if this is a gas molecule, when it hit and come back, what happened? Is there a change in momentum? When the gas molecule hit and bounce back, is there a change in momentum? Yeah, there is a change in momentum because the direction changes. When the direction changes, the momentum also change. And whenever there is a change in momentum, there is always a force, because rate of change in momentum or change in momentum divided by time, there is always a force. So because of this force, the gas molecule exert pressure. It's why D is not an answer. It is written when a molecule rebound, there must be a change in temperature. The temperature of the molecule does not change because they only changes the direction. When they change the direction, there is a change in momentum. So if you have a container which is filled with the gas molecules, and gas molecule rebound. The term, what is the meaning of this term rebound? Rebound means bounce back. It means when something hit and bounce back, we call rebound. So it hit and it come back. So whenever there's a change in direction, all of them you can see are scalar. Scalar quantity does not, energy is a scalar quantity, does not depend on direction. Speed is a scalar quantity, does not depend on direction. Temperature is a scalar quantity, does not depend on direction. But momentum is a vector quantity. If there is a change in direction, it means there is also a change in momentum. Vector quantities changes with the direction. So momentum changes. As the momentum change, there will be a pressure on the container. Is it clear? So if here the momentum is mv, here the momentum will be m minus mv because it changes the direction. What could be the answer for question 6? So when molecule gas rebound, the wall experience a pressure. What caused this pressure? The change in momentum of the molecule. Question 7. What could be the answer for question 7? Yeah, question 7C is the right answer. Question 9. The temperature of the liquid means the liquid which is left. Question 9. So what happened? The molecule will escape. The most energetic molecule will escape. The term energetic means like it is the term derived from energy, like the molecule, the particle which have energy, we call energetic. Less energetic means they have less energy. More energetic means they have more energy. So what happened when evaporation occurs? So most energetic molecule at the surface gain energy from the surrounding and escape. So as these molecules escape, the molecules which are left behind, those molecules will have, so the particles or the molecules which are left behind, they will have low energy. So if the particle will have low, high energetic molecule escape and low energetic molecule left behind. So that's why the temperature will go down. So correct answer is C. The most energetic escape and the less energetic remain. That's why the temperature of the remaining liquid will goes down. Question 10, what could be the answer? So again, the similar answer, the molecule basically exerting a pressure is mainly due to change in momentum. Question 11. A piece of melting ice and a beaker of a boiling water. It is in the lab at 20 degrees centigrade. What happened to temperature of a melting ice and what happened to temperature of a boiling water? So whenever the substance change the state, there is no change in temperature. That's why A is the right answer. Whenever the substance change the state, there is no change in, if something is melting or something is boiling, there is no change in state. There is no change in temperature. Only the change in state will occur. Question 12. Question 12. Which represent a Brownian motion? A is actually representing the Brownian motion. The diagram shows an air-filled rubber toy. A child sit on the toy and its volume decrease. The temperature does not change. There is no change in temperature. The volume only decreases. How does the air pressure in the toy changes and why? Look, if the temperature is not changing, if there is no change in temperature, it means the speed should not change. The speed of the particle will be constant. If speed is same, they will not move quickly. So the answer is D. The air molecules strike the rubber, means they will hit the wall frequently, but with the same speed because the temperature is not changing. The temperature cause, the change in temperature will cause the change in speed of the particle. So they will have greater number of collision. Question 15. So because they are hit by the air molecule, so that's why A is the right answer. Question 20. A solid is heated from a room temperature. The graph shows how its temperature changes with the time, at which time it becomes completely liquid. A, B, C, or D. So originally it's a solid. Then here solid is converting into liquid. Here you will have liquid, and here liquid is converting into gas. So till A actually it was solid, B it is solid and liquid, At C, because now the temperature start to change, so means this will be liquid. And after D, it will be liquid and, or at D, it will be liquid and gas. So C was the right answer. Question 22. Average molecule of remaining decrease and temperature also decrease. That's why A is a correct answer for this. Question 25. Yeah, D is the right answer, because what happened, the swimmer, the most energetic molecule of the water escaped and it cooled down her skin. Question 26. A circular metal disc is heated. Which quantity decreases? So its density will decrease, because what happened, as the substance expand, its volume increase, so its density will decrease. Question 27. What could be the answer? 27. Which molecule likely to escape? A, B, C, or D? So most energetic molecule at the surface will escape. That's why the molecule likely to escape is A. #29.